Did you know there's a new way to do zero-knowledge proofs that uses way less memory? Like, instead of using tons of space, it only needs a square root of the trace length.
Wait, seriously? That's wild. So, how does it manage to operate with so little memory? I mean, isn't memory typically a huge constraint in these systems?
Right? It utilizes something called a streaming prover. It processes data in blocks instead of loading everything into memory at once. Super efficient.
That makes sense. So it keeps the working set manageable. But are there trade-offs? I can't imagine it's all sunshine and rainbows.
Good point, they do mention some limitations, like the air demo being compact. It's like a prototype, so you do need to customize it for real applications.
Ah, so they're kind of setting the stage but not handing you a complete solution. What about security? This stuff can be tricky.
Exactly, they emphasize pairing checks are enforced and they even run tamper tests. It's designed to fail if something's off, which is reassuring.
That's a solid layer of security. But I wonder how this compares to traditional ZK pipelines. Are the performance benefits really noticeable?
Interesting question. Traditional methods need OT memory, which can be massive. The sublinear approach could be a game changer in practical scenarios.
So it could make ZK proofs viable for applications where memory is a constraint, like mobile devices or low-power systems.
Exactly, think about it. Streamlining the process could open up zero-knowledge proofs to a whole new set of use cases.
But what about the implementation complexity? It sounds like there's quite a bit to manage with streaming and aggregation.
True, it's not just plug and play. You still need to integrate with your existing systems, which can add complexity.
And there's always that learning curve, right? I mean, understanding how to adapt your logic to this new streaming model could take time.
Exactly, but the payoff might be worth it if it means handling larger datasets without running into memory issues.
I can see that. Speaking of datasets, do they mention how this affects the speed of verification and proving?
They do, the way they've structured the phases seems optimized for speed. Each step builds on the previous one without bogging down.
That's fascinating. So it's not just about saving space, it's also about making the whole process faster. Win-win.
Totally, it's like they've taken the traditional model and compressed it into something way more efficient.
I wonder if this could change how we think about scalability in cryptographic systems. It could really push the boundaries.
Definitely, and if they expand to support more than just BN254, it could broaden its applicability even more.
That's a good point. Diverse use cases would definitely help solidify its place in the ZK landscape.
Right, but we should also think about potential drawbacks. Like, do they mention any specific weaknesses of this approach?
They hint at the limitations, primarily about it being a demo. So, while promising, it's not fully mature yet.
That's fair, it's like the prototype phase, great potential, but users should tread cautiously until it's more robust.
Exactly. It'll be interesting to see how the community responds and develops it further.
I bet, and think about the educational aspect. This could help demystify ZK proofs for a lot of developers.
True, if it's easier to implement, more people might explore ZK tech. It's a gateway into the cryptography world.
I love that perspective. So it's not just tech innovation, it could foster a whole new wave of interest in cryptography.
Totally. And as we see more real-world applications, it might even lead to more investment in these technologies.
For sure, but we should also keep an eye on the ethical implications. With more access comes more responsibility.
Absolutely. Understanding the impact of these technologies on privacy and security is crucial.
So in a nutshell, this sublinear space approach is a fascinating development in ZK proofs, but it's still in its infancy.
Exactly. It offers exciting possibilities, but like any new tech, it warrants careful consideration and evaluation.
I think we've uncovered a lot here. It's exciting to think about where this could lead us in the future.
Definitely, I can't wait to see how this evolves. It's like we're witnessing the beginning of a new chapter in cryptography.
And who knows what other innovations are just around the corner? Let's keep this conversation going.
For sure. Next time, let's dive deeper into how these ZK proofs can affect blockchain and decentralized applications.
Great idea, there's so much to unpack there. Who knew zero knowledge could lead to such rich discussions?
Right? It's like peeling an onion. Every layer reveals something new and interesting.
Exactly, can't wait to explore those layers with you until next time.
Until next time.